All right, so we are going to talk about the last section in our trig unit. I know, very short compared with analysis, but this is perhaps the most important part of our unit, which is application of sinusoidal models. Before I get started, I want to address a student question on the homework from yesterday. I believe it was 16B. The question was just providing another example of how to find the unknowns for a general sine or cosine function. So I wrote out the steps here and I just want to talk you through them. If you're given 2 points on a graph, and I want to emphasize the importance of this because if you are doing a modeling investigation, especially for your IA, you're going to have to come up with the equation yourself. Let's say if it fits a sinusoidal model. And in order to do that, you usually have to work with given points on your regression equation. So just like we studied linear regression and quadratic regression and power regression, there is sinusoidal regression as well. And to find that equation, you're going to have to be able to find the unknowns. To find those unknowns, you're going to have to work with points on the graph, right? And then adjust the transformations accordingly. So this is a very important process when you are working with sinusoidal regression. Okay, so equation 1, first of all, I'm going to work with that leftmost point, 30 degrees, comma 1/2. And you can see that I simply substituted the x and y value to start into that general equation that was provided to me. So right here, you can see that substitution. Now, when I simplify, I get the cosine of 60. The same thing is true here, except I'm using that second point. I'm just substituting 90, and when I simplify, I have 180. Now, while you do have access to your calculator on exams, I would say knowing your unit circle very well and saving the time it takes to input this information into your GTC will prove very beneficial to you. So what I mean is, when you look at cosine 60 degrees, what is that on the unit circle? Well, that's 1/2 or 0.5. When you think about the cosine of 180, what is that on the unit circle? Well, that's -1. So I did that because I know that these functions have cosine of 60 here and cosine of 180 here. So when you realize that that's 0.5 and -1, you end up with this simplified equation and this simplified equation here. So 0.5 is equal to 0.5a, or 1/2 a plus d, and -4 is equal to -a plus d. And then I simply plug it into my calculator. I go to algebra, and then I'm going to systems of equations or simultaneous equations. And then instead of using an a and a d, because your variables are x and y, you just want to use an x and a y. And then you have the graphing calculator solve it for you, or you can solve it algebraically by hand, you can solve it graphically, whatever way that you want to solve. And then you get your missing a and d values here. So you simply plug this in to your general equation. So let's go ahead and do that now. So you've got f of x is equal to 3 cosine 2x minus 1. That's your answer. I hope that helped. If you have any questions on the homework, please feel free to send me your questions and I will try to answer them on the next video. Now, if I get a lot of questions from a lot of different students, I'll just pick and choose the most frequently asked questions or the ones that are the most thought-provoking, and I will put them on video for you. All right, trig modeling. We're going to take a look at 2 weather pattern investigations, and hopefully you'll see with each of these questions, they're very different. One is going to give us the equation and have us analyze the graph. The other is going to give us the graph and have us produce the equation to model the graph. And so again, if you end up doing an IA that focuses on mathematical modeling, which is very popular for students and in particular SL students, you're going to want to pay attention to this process and become very familiar with it. So it says the average daytime temperature for a city is given by the function, where t is the time in months after January. Sketch the graph of d against t for the domain 0 to 24. Before I do that, I want to figure out how to partition or break up my x and y axis. In order to do that, I need to determine my period first. So remember, with all of these problems, while it is certainly allowed for you to work with radians, the focus is on degrees. I'm not sure why this course has chosen to take out radians, but that's not something that's required in the syllabus. So for these problems, it's not necessarily required either, and we're going to be working with the unit that will be tested, which is degrees. Okay, so remember your period. Instead of 2 pi, that's of course if we're working with radians, we're going to work with 360 degrees. We're going to divide that by the b value. The b value is the coefficient in front of t. So divide that by 30, and you get your result, which is going to be 12. That's how many months after January it takes to complete one full cycle. Because remember, t represents the time in months after January. So we're going to break this up. So go ahead and break up your 12 into fourths. So you have 3. You're going to start with 3 months after January, and you're going to keep adding 3 each time. So we're going to go ahead and work with that. Let's outline our principal axis and our amplitude so that we know how to apply transformations to the table of values that we're going to use to graph the function. So our principal axis is given to us. It is 20. So our principal axis is 20. Specifically, it's an equation, y equals 20. Notice that I put y equals 20 there. I want to emphasize that your principal axis is an equation. If you have a problem that asks you for the principal axis, you want to put an equation. Just like your axis of symmetry is an equation, your principal axis is an equation as well. So now let us look at the amplitude. Well, the amplitude is also given to us as 5. Take note that both of these will be affecting your y value or your output temperature. When you perform transformations, you also have to keep in mind order of operations. So we're going to multiply by 5 first, and then we're going to add 20. Also, keep in mind your particular domain. That is something that you do not want to forget. Your domain in this case is from 0 to 24. All right, you're going to need a lot of space when you write out that table. So let's go ahead and write out our table. I'm going to choose a different color here. Let's go ahead and go with blue. So I'm going to write out my table. I'm going to leave lots of space with the output column because I know I'm going to perform some transformations. Now, with the period, dividing 12 by 4, I get 3. So I'm going to go ahead and start with 0 here because that's part of that domain. Then I'm going to add 3. Then I'm going to add 3 again, etc. all the way until I get to 24. All right, so let's go ahead and fill this out. Well, typically with a cosine function, which this is, what is the cosine of 0? Well, the cosine of 0 is 1. So it starts out with 1, and then it goes to 0, and then -1, and then 0, and then 1, and then 0, and then -1, and then 0, and then 1. All right? Now, we have transformations that we need to apply. Because we have an amplitude of 5, I'm going to multiply by 5. So each of these is going to be multiplied by 5 here. So multiply every output value by 5. Once I get that result, I'm going to add 20. So I'm going to add 20, add 20 to each of these output values, because I need to account for that principal axis that I have in the original equation. Now, you'll notice that because this is a sinusoidal function, it is periodic in nature, which means it's going to repeat, right? So it's going to repeat its cycle after 12 months from January. So you start out with 25, then 20, then 15, then 20, then 25, so it's repeating, then 20, then 15, then 20, then 25. All right, this is enough information for me to graph the function that is modeled by the equation. So I'm going to go ahead and label my graph. You go ahead and do so, graph the function, label the principal axis, and let's check our results afterwards. So pause the video now and go ahead and graph the function on graph paper. All right, so as you can see here, I've got my graph. I partitioned my graph paper to reflect the points that I need to examine. I don't have to label every single point, obviously, just the most, I guess, apparent ones, so your maximums and your minimums, as well as the principal axis, so that was y equals 20. So I modeled that cosine wave there. Now let's take a look at part B. It says find the average daily temperature during May. Well, you have to look at the question and see what this function represents. It's the average daytime temperature for a city, where T is the time in months after January. So how many months after January is May? May is 4 months after January. So in this case, for part B, let's go ahead and do that here. Let me choose a different color. Let's do black. So for part B, you are looking at the x value of 4. So it's really important that you interpret these questions correctly. Remember, again, this class is called Applications and Interpretation, so we are applying our mathematical knowledge of sinusoidal functions, and now we are interpreting the function and what it represents in the context of the problem. So now I'm going to take 5 times the cosine of 30 times 4 plus 20. So I'm just plugging it into that equation. So you get 5 times the cosine of 120, and this is in degrees, plus 20. Now you need to remember, again, you can save yourself a lot of time if you know your unit circle. So for example, if I look at 120, I think what's the reference angle of 120? The reference angle of 120 is 60 degrees, because 60 degrees plus 120 is 180 degrees. And so I think of the cosine of 60 degrees. The cosine of 60 degrees is 1/2. 120 is in the second quadrant, and I know that all students take calculus. So in the second quadrant, only sign is positive. So that means that for 120, you're going to have a negative 1/2. So the cosine of 120, in other words, is negative 1/2. So 5 times negative 1/2 plus 20 is equal to 17.5. What is that? Degrees Celsius. All right, let's move on to C. Find the minimum average daytime temperature and the month in which it occurs. The minimum average daytime temperature occurs at the minimum point of your graph. So right here and right here. So 6 months after January or 18 months after January. What month is that? Well, that's going to be July. So the answer to part C is July. And in July, you look at your output value. That's 15 degrees Celsius. Okay, now we answered all of those questions. Now, keep in mind that because I am working with a specific question in context, I need to remember to label my X and Y axis. Also remember that you don't want to put a point here. Actually, we do. Sorry about that. I put an arrow. Why do we need a point there? Well, because of the domain restriction. I guess I just did that to test you. So if you were wondering why I put an arrow there, well, you were probably right to question me because we've got this domain stopping us at 24, so we want to put a dot there. Otherwise, we'd have to put an arrow, right? So that does make a really big difference. Okay, let's move on to the next question. All right, before I begin this question, when you check to see or to verify the two different trigonometric functions that I'm going to find that model this graph, please remember that you want to keep your calculator in degree mode. Okay, so let's take a look. It says consider the mean monthly temperatures for Cape Town. Write two different trigonometric functions that model this situation. Now, you'll notice that the graph is for a 2-year period. The table is for 1 year, but also notice that because they don't want points to overlap, they didn't go January, February, March, April, May. Here, they went January, March, May, July, September, November, January, March, May, July, September, November. Okay? Because again, they're assuming that these temperatures stay constant. That's not necessarily the case. And they're also not wanting the points to overlap by just doing January, February, March, April, May, June, July, etc. Now, what's really important here is how we find the equation to model this. Because like I said, if you're going to do a modeling investigation or modeling IA, oftentimes with sinusoidal functions, you're concerned about finding the equation. So again, let's start with finding our period and our principal axis and our amplitude. So our period looks to be 12 months. So let's verify that. Very simply, you can see on the graph that from July to July, 12 months time, your graph starts its cycle over again. That's one way, again, to verify your period, either from max to max or min to min. You're just looking at corresponding points to see when the cycle begins again. So 12 months, the cycle will begin again. So your period in this case is 12. Period is 12. Now, in order to find our equation, remember the general equation for a sinusoidal function. Now, in this case, we're actually going to work with horizontal translations. And I say that because even though you're not going to be assessed on horizontal translations, your particular investigations, especially as it concerns an IA, if you work with sinusoidal functions, you're going to have to know how to translate to the left and to the right. So this really is the general form that we're looking at. Although when it comes to your own assessments for paper 1 and paper 2, you're going to have a simplified general form where that C is dropped. Okay? Now, I gave you this on purpose because the C is not going to be dropped here. This is not a textbook question for applications. It's one for SL, the old SL course. But again, really important to consider here. So let's go ahead and find the B value, this B value here. How we do that, of course, is we understand that in order to find the period, it's the same thing as 360 divided by a constant. That's going to be equal to 12. Now that constant very simply is 30 because 360 divided by 30 is 12. So that's that B value. Okay, let's move along to our D value. So our principal axis in this case. So let's identify a maximum point and a minimum point on the graph. Go ahead and pause the video and identify your maximum point and your minimum point. All right, so here, your maximum point is 128, and your minimum point is 615. And you can very easily identify that on the table that you're given. So remember, your D value is the average of your maximum and minimum points because it splits your graph in half. So you're going to take 28 plus 15 and you're going to divide that by 2. You get 43 divided by 2, which is equal to 21.5. That's your D value. So we've got our B value, which is 30, and we've got our D value, which is 21.5. Now let's find our A value, or our amplitude. Now our amplitude in this case is subtraction, right? It's just the distance between that principal axis and either your maximum or minimum. So in other words, what that means is you take 28 minus 15, divide that by 2, you get 13 over 2, which is equal to 6.5, which is your A value. Okay, so we've got all of our primary variables here except for our horizontal translation. So let's think about this horizontal translation, because remember that you can either fit this data with a sine or cosine function. It's up to you. And I would encourage you to take out your graphing calculator when we're done and graph both of those equations and see that they overlap, that they're the exact same function. It's just that we have different transformations performed on them, and in particular, the horizontal translation, in order for this to happen. So let's find one equation. Let's work with cosine. Remember what I said in the last video. You need to know the behavior, the basic behavior of your sine and your cosine graphs. Well, your cosine graphs always start at either a maximum or a minimum. That's how cosine functions, because the basic parent function starts at the point 0, 1. Whereas your sine function starts at the principal axis 0, 0. So cosine starts at either a maximum or a minimum. Sine starts at the principal axis. So let's work with cosine first. If we know that we're going to start at either a maximum or minimum, then on this graph, I'm going to want to choose either a maximum point or a minimum point. So what I'm going to do is I'm going to take a look at my first minimum point. So my first minimum point on my graph is in July. So how far over to the right is July? Well, counting point by point, 1, 2, 3, 4, 5, 6, 7. So it's 7 to the right. Also, your cosine of x starts at a maximum, not at a minimum. But because we're starting at a minimum, remember, like the Ferris wheel problem, I'm going to want to reflect this graph. So that means my basic function for the cosine equation that fits this curve is negative cosine of x. Now I'm going to go ahead and plug in my A and D and B value. So I get negative 6.5 cosine of, now again, we're using the general equation in pink here. So let's go ahead and just use another parentheses. So 30 times x minus 7 plus 21.5. Okay, that is the general equation that will model this data in cosine form. So let's think about sine. So sine starts at the principal axis. So what is our principal axis? Well, our principal axis is y is equal to 21.5. Was 21.5 on the graph? It should be, so let's take a look. So 21.5 is in month October. So right here. Well, how many months over is that? Well, that's 10 months, right? So that's 10 months. There is no reflection necessary here. So in this case, we have a basic sine function of sine of x. So no reflection is necessary here, because if we translate all the way over to October, then we start at the principal axis, just like a normal sine function starts at the principal axis. So in this case, we have 6.5 sine of 30 times x minus 10, because 10 over from that first point is October, which is the principal axis, plus 21.5. Now graph both of these and see, are they the same function? They will be. Okay, so just remember that your graph needs to be in degree mode, okay, when you check that out, because we did not work with 2 pi here, we worked with 360 degrees. Your task for today is to complete the homework for sinusoidal modeling, also to check your answers from yesterday's homework, and in the homework you'll find an investigation. Now the investigation is going to assume that you know how to work with the pink equation. Again, it's not going to be something that's going to be assessed on your paper 1 or paper 2. You will have a much easier time without the plus c. However, again, it's very important that you know how to work with the horizontal translation. Okay? When you're finished, make sure you upload the homework to your homework tab, and then next week we're going to start a review. I'll have a Zoom meeting with all of you, which I'm super excited for because I haven't seen your faces in a very long time. I'll walk you through the testing procedures. I'll ease your mind and ease your stress about this. Don't worry about it. If you've been paying attention, like I know all of you have been, don't stress about this exam, okay? Have a nice weekend. Don't worry. I will prepare you for this. You will be prepared and you will be fine. And then we will have a paper 1 and paper 2, okay? But please make sure you attend that Zoom meeting, because I'm going to walk you through a practice question and sort of see how we want our desks to be laid out, because I haven't actually given an assessment on Zoom yet, so you're my guinea pigs. And I'm lucky because you have had teachers that have given you Zoom assessments, so you can help me out as well, and talk about what has worked and what has not worked. So I really look forward to seeing you then, and I hope you have a great weekend. It's Miss Nguyen again. I was just listening to what I just said, and I said the pink equation. That's an expression. Just, I'm a bit of a nerd. I want to make sure that I have correct terminology. Plus, correct terminology is important. Without the equal sign, it's an expression. Okay, that's all I wanted to say. Bye.